Today I'm going to talk about sigma notation, arithmetic series, and hopefully I'll be able to get to some geometric series questions. First of all, let's start out with sigma notation. If you remember from last year, the Greek letter sigma looks like an that's the uppercase sigma, kind of looks like an E. And you have some lower bound, and you have an index. We'll let the index be J in this particular example. Let's say J is equal to 5 up to 9 of 5J plus 3. What that means is you're going to start with J equals 5 and then increase J by 1 to get to 6, 7, 8, and when you finally get up to J equals 9, that's when you stop. And because this is a summation symbol, then that means you're going to add the numbers together. So to expand this out, it's 5 times 5 plus 3. That's the first term of this expansion. And then you're going to add to that 5 times 6 plus 3. Add to that 5 times 7 plus 3. Add to that 5 times 8 plus 3. And add to that 5 times 9 plus 3. And probably with some sigma problems, I won't let you use a graphing calculator on them because we probably remember from last year there's just a button that you have to press in order to do a sigma sum, like in this example. So if you want to add all of these together, you can just 3, 6, 9, 12, 15, and then it's 5 times 5 plus 6 plus 7 plus 8 plus 9. And when you add those together, you should come up with the answer of 190, I believe it is. So no calculator, because the calculator is a crutch for the sigma notation. Sometimes you're going to be given a set of numbers added together, which is called a series. And then you're going to be asked to write it in sigma notation. All right, let's just start with this this first one: 5 plus 9 plus 13 plus 17 plus 21. First of all, I should recognize that this is an arithmetic sequence. The D value is equal to 4. And the first term is 5. So if I wanted to write this out as a formula, this formula says that the nth term is equal to 5 plus 4 times n minus 1, which is the same thing as 4n plus 1. So that's the formula that we're going to use. And when we come up with a formula for this set of numbers, that's the formula that we use inside our sigma. So we'll start out writing a sigma. We've got 4n plus 1. And then the next thing we're going to do is we're going to count up how many terms we have. 1, 2, 3, 4, 5. We have 5 terms. So we're going to let the n value, make sure this variable matches whatever the variable is here. You could have used an I or a J or any other variable you want, but we'll use n because that's what we used here. So starting with the first term, ending with the 5th term. Be careful because I've seen some students put a 5 down at the bottom and a 21 up on the top. This number, these upper and lower bounds, do not correspond to the terms, but they correspond to the term numbers that you have. So the first term plus the second, third, fourth, plus, and then when you get to the 5th term, you're going to stop. All right, let's do another one. Let's do 25 plus 20 plus 15 plus 10 plus 5. Let's write this in sigma notation. So we'll write that in sigma notation. So what we have is the nth term formula is equal to the first term, and this time d is negative 5, so minus 5 times n minus 1. So the nth term's formula is negative 5n plus 30 when you combine like terms. So if you write this in sigma notation, we start with the first term, second, third, fourth. Oh, this one has 5 terms also. So however many terms there are, that's the upper bound here. And you start with n equals 1, and our formula is negative 5n plus 30. Sometimes you're asked to write in sigma notation for something that's not an arithmetic sequence. Let's say you're asked to write in sigma notation it's a funny looking sigma. Let's say have 3/4 plus 4/5 plus 5/6 plus 6/7 plus 7/8 plus 8/9. All right. So what we're going to do is, this is how I try to figure out what the pattern is. I put the n value, the term number above it. So this is the first term, second term, third term, fourth term, fifth term, and sixth term. And you can see the numerator is an arithmetic sequence. The denominator is an arithmetic sequence. So you can set up each one individually if you want numerator and denominator. Or maybe you can quickly recognize that because these are just going up by ones, the d value is equal to 1 in the numerator, the d value equals 1 in the denominator. So what this is n plus 2. For each one of these n values up here, you're just going to add 2 to it to get the numerator. So how many terms do we have? 1, 2, 3, 4, 5, 6. So we have n equals 1 to 6. The numerator is just n plus 2, and the denominator is just n plus 3. And that's writing that in sigma notation. So hopefully that's a quick review for you of sigma. The next thing we're going to talk about is series, arithmetic and geometric series. A series is just a sum of terms in a sequence. So what we've really done in the previous, not this example because that's not arithmetic or geometric, unless you consider the numerator and denominator each independently. You can look at this other example that I had, these couple of examples here. This is really called an arithmetic sequence or series because you're adding the sequence of numbers together. So here's a series, and here's another arithmetic series. A series is just a sum, like I said, of terms of a sequence. Okay, there's a formula. Last year it was on your formula sheet. This year I'm going to ask you to memorize this, of course. So the formula for the arithmetic series for the first n terms is S stands for sum, n stands for how many terms we're going to be summing, and that is equal to the number of terms we're summing times the first term plus the nth term all over 2. Like I said, this is on a formula sheet last year for your Algebra 2 Regents exam. This year you must memorize this. Okay. For example, let's say I'm going to ask you to find the first 20 terms of the following series. Example number 1. Let's say 4, or find the, I'm sorry, not find the first 20 terms, but find the sum of, find the sum of the first 20 terms of 4, 8, 12, 16, 20, ... all the way up to 20 terms. So how we write this out is we're going to find the sum of the first 20 terms. That is equal to, this n value is 20. I'll write that off to the side, n equals 20. So we have 20 times the first term. The first term was 4. Now the nth term, the 20th term, we don't know what the 20th term is, but if we wanted to figure it out from what we learned yesterday, the nth term is equal to the 4th term plus d times n minus 1. So we can substitute this an into this an piece right here. These two are the same an's. Or we can just figure out what the 20th term is. It is equal to 4 plus, 4 times 20 minus 1. 4 times 19 plus 4. Should be equal to 80. So the 20th term is 80, all divided by 2. So this is 10 times 84, which is 840, I believe. So there's the sum of the first 20 terms, just using this formula up here. Let's do a couple other examples. Let's say we're asked to find the first 20 terms of 6 plus 16 plus 26 plus 36 plus 46 plus, all right, the sum of the first 20 terms is equal to 20 times the first term, 6, plus the 20th term. Oh, we got to find the 20th term. So the 20th term is equal to the first term plus the d difference is 10 times n minus 1. 20 minus 1 is 19. So what we have is 190 plus 6. So 196 goes in for the 20th term, all over 2. So we have 10 times 202, which is 2020, I believe. Let's do another example that's a little bit different. Let's say I give you the 4th term is 2, and let's say I give you the d value is negative 2. And I want you to sum the first 20 terms just given that information. So what we need to know first is what is the first term. And we need the 20th term, because we can't use that formula unless we know those two terms. All right, so from the formula that we learned yesterday, the an equals a1 plus d times n minus 1. If you rearrange that, the first term is actually equal to the nth term minus d times n minus 1. That's just a modification, and make sure you know the difference. If I put the an on this side, then this minus becomes a plus, right? Or if you want to add to both sides here, you get an equals a1 plus d times n minus 1. I just moved it over to the other side. So since we know the 4th term, we can figure out the first term because it is the 4th term minus, now d is negative 2, and n is 4. I told you the 4th term was 2. Negative 2 times 3 is negative 6, and 2 plus 6 is 8. So the first term is equal to 8. Now we need the 20th term. The 20th term is equal to the first term plus d times n minus 1, which is 19, first term, d n minus 1. So the 20th term is negative 38 plus 8, I believe that's negative 30. So now we can say the sum of the first 20 terms is equal to n, we have 20 terms, times the first term, which we figured out to be 8, plus the 20th term, which is negative 30, all over 2. And that's 10 times negative 22, which is negative 220. All right, we'll do one more of those. Fourth example. Let's say I give you the third term is 13, and I give you the d value is equal to 3. We need the first term, and we need the 20th term. So the first term is equal to the third term minus d times n minus 1, well, n is 3, because we were given the third term, n equals 3 up here. Well, the third term is 13, d is 3, 3 minus 2 is 1, so that is equal to 10. So our first term is 10. That doesn't make sense. Oh, 3 minus 1, which is 2. Sorry, 7. The first term is 7. Did I make that mistake down here? Okay, now we need the 20th term. The 20th term is equal to the first term, 7, plus d times n minus 1, 3 times 19, plus 7 is 64. So now we have the sum of the first 20 terms is equal to n times the first term plus the 20th term all over 2. 20 over 2 is 10. 10 times 71 is 710. We'll pause for a second. And then the last thing that I'm going to talk about today is the formula for finding the sum of the first n terms of a geometric series. And last year, this formula was on the Regents formula sheet, so you didn't have to memorize it, but I'm going to ask you to memorize it this year. So the first n terms is called Sn, and that's equal to the first term times 1 minus the common ratio raised up to the nth power divided by 1 minus r. So you need to memorize this. So let's find the first 12 terms of this series. Find sum of first 12 terms of this series. 2 plus 8 plus 32 plus 128 plus ... So I've got 4 terms out here. And we know that this is geometric because 8 divided by 2 is the same thing as 32 over 8 is the same thing as 128 over 32. So the R value is 8 over 2, which is 32 over 8, which is 128 over 32. Anytime you divide two consecutive terms, if you always come up with the same number, that's the common ratio. So this common ratio is 4. So if we want the first 12 terms, then n equals 12. So the sum of the first 12 terms is equal to the first term, 2, times 1 minus, the R value is 4, raised up to the 12th power, divided by 1 minus 4. And I would let you use, of course, a graphing calculator because who knows what 4 to the 12th is. So if we put this into our graphing calculator, hopefully I did it right a couple minutes ago, I got the answer of 1,118,4,810. So it looks like it's 11,184,810. These sums get pretty big if the R value is anything more than 3 or 4. So that's only the first 12 terms. So let's do a couple more examples. Let's do the first 10 terms of, let's say, 1 minus 6 plus 36 minus 216 plus dot, dot, dot. So if you do a common ratio, negative 6 over 1 is the same thing as any two consecutive terms divided by each other. This R value is negative. It is negative 6. So the sum of the first 10 terms is the first term, which is just a 1. And now you just have to be careful when you put this in your calculator. It's 1 minus, now this R value is negative, so this negative 6 has got to go in its own set of parentheses like this. And then you raise it up to the nth power, n is 10. If you forget these parentheses, then it's not going to compute right because negative 6 to the power of 10 is going to be a positive number. Forget the parentheses and you're going to get a negative 1 by mistake. So just make sure you double up those parentheses. And on the bottom, 1 minus R, 1 minus a negative 6, which is 1 plus 6, which is 7, will go in the denominator. So you should try putting this in. Make sure you get what I get. Hopefully I'm right. I get the sum is equal to negative 863,8025. So it looks like it's negative 8,638,025 is the first sum of the first 10. And hopefully you're checking me out or checking my answers out to make sure that they match with yours. And then the last example I'll give you for the geometric series is, let's say we're asked to add 8 plus 4 plus 2 plus 1 plus dot, dot, dot plus 1 over 16. Well, we don't know how many terms are in this geometric series here, but since it looks like it's pretty easy to compute the next, let's just fill it in ourselves. So it looks like we're dividing it by 2 to get to the next. So this next term would be 1 over 2. This next term would be 1 over 4. The next term would be 1 over 8. And then finally we would get up to 1/16. So it looks like we have 1, 2, 3, 4, 5, 6, 7, 8 terms. So we can say, well, n is equal to 8. And so the sum of the first 8 terms is equal to the first term times 1 minus, now the R value is 4 over 8, which is a half. Be careful. A lot of people look at this and they say the R value is 2, but it's not because it's 4 divided by 8, not 8 divided by 4. So 1 minus a half, I'll put 1/2 in parentheses, and we're raising it up to the power of 8, all over 1 minus a half, which is just a half in the denominator. Hopefully I plugged this into my calculator right, and my calculator is telling me that this answer is 255 over 16, or if you got a decimal value, you can write the decimal value as 15.9375. I like the fraction better. All right, so that's it for today. And hopefully you have some time to memorize those formulas that we went over today.